Welcome back to another edition of TEC Tube. Today we're going to go through the fundamentals of variable refrigerant flow systems. You probably have heard of these systems before. You may have even seen one or two of them. We've been doing them at our office since 2008. Today we're looking at a Toshiba Carrier one. Toshiba Carrier is a joint venture between obviously Toshiba and Carrier. This one happens to be a 6-ton. It's pretty big for a 6-ton, but this guy's going to do a lot of work for us, a lot of heating BTUs, a lot of cooling BTUs. We have the one in the lab tied to 4 indoor units, and this is a 3-pipe version, and I'm going to explain to you today what all that means. So what exactly is this VRF type system, right? So what pieces do we have involved? So at its heart, it's going to be an air conditioner and heat pump. It's usually going to be a heat pump. Air conditioners are pretty rare in this market, so it's going to be a heat pump, and there's going to come in 2 flavors, a 2-pipe or a 3-pipe flavor. So outdoor unit's going to be outside, obviously, and then we're going to have any combination of indoor units that we want. Now you're probably going to have 3, 4, 5, 6, 10 high walls, or you may have all ducted units, or you could have a weird combination like I happen to have on the screen, where I have high walls, ceiling cassettes, ducted units, fan coil style units, all mixed and matched together. And then this outdoor unit is going to send refrigerant to all of those guys, and that guy will have his own independent valve that'll open and close, or modulate rather, to let more or less refrigerant in, deciding if that zone wants any cooling or any heating. All kinds of indoor units that we can mix and match, like the ones I just mentioned, and even now we can even pair it up with rooftop units. So one of the evaporators, or one of the indoor units if you will, can actually be a rooftop unit that's sitting outside, getting refrigerant fed to him by one of these outdoor units. For the smaller stuff, we typically have this stacked style with a horizontal discharge on it for the condenser air. And then for the bigger tonnages, like 6 tons and up, you'll see this vertical discharge air style. And those guys can get bigger and bigger. We can take them, we can bolt them together. So we can take multiple sizes and connect them together to get larger and larger tonnages. So you can do anything from a little 3-ton, office space to a 30-story high-rise building with this. It's pretty flexible in that regard. And you may or may not have multiple systems. So I can manifold them together on the outdoor side to connect them up. So you can buy these in a heat pump version or a heat reclaim version. The heat pump version is typically 2 pipes. The heat reclaim is 3 pipes, although that's not always the case. The heat pump version is the easiest to explain. It works exactly like a regular heat pump. If you're not sure how a heat pump works, we have videos on that you can watch, and you can check that out and learn about the refrigeration cycle. So I have my 1 or 2 outdoor units, in this case 2 outdoor units, manifold together. They send refrigerant down to all these individual units down this piping grid. And each one of those takes refrigerant off. It's kind of like ductwork. It starts out with a large pipe, and it gets smaller and smaller and smaller as you get further away from the unit because you keep branching off from there. The heat recovery is typically a 3-pipe system. So I'll have multiple pipes coming down the middle of the building, and then they'll be going into each individual unit. We need the 3 pipes because we're going to run simultaneous heating and cooling, and I'll explain exactly how that works. So if I have a 3-pipe system, or if I have a heat reclaim system, I have 3 flavors of that shown here on the left. So what I was describing was a 3-pipe system. So 3 pipes leave the outdoor unit, they go to the indoor units. Each one of them has a selector box where it picks either hot or cold refrigerant and sends that to the indoor coil. You could also have ones where I have refrigerant come down into a larger selector box. Instead of a 1-to-1 relationship of selector box to indoor coil, I can have a selector box feeding 2, 3, 4 indoor coils. Or I could have a 2-pipe heat reclaim where I have a very, very large flow selector box that all of the indoor units have to home run their piping back to. And there's different combinations of that. So what that might look like is you might have outdoor unit sending refrigerant down the 3 pipes. These 2 guys are sharing a selector box. This guy has his own selector box, and then these 4 are sharing one larger selector box. In these scenarios, even though the outdoor unit is providing simultaneous heating and cooling, each selector box can only do one of those modes. So these 2 guys together on the bottom down here, they would either be in heating together or they'd be in cooling together. Now one of them could shut off, or one of them could ask for less heating or cooling, but they can't ask for an opposite mode. They gotta go together with the selector box. But these 2 guys could be in heating while this guy's in cooling, and this guy could be in heating or cooling. So each selector box can be in one mode or the other, but everybody downstream of him has to be in the same mode. So how's that gonna work if you got multiples there? So this is a simple example. We have 2, 8 tons of cooling. So we have 8 indoor units, or 8 evaporator coils as we historically would have called them. And then outside, here's my condensing unit, which has 8 tons of condenser coil and 2 compressors in this case. It has 1 fixed speed compressor and 1 variable speed compressor in this example. Sometimes you're gonna have 2 variable speed or even 3 variable speed ones. More variable speed, the more flexibility you're gonna have, obviously. So if they're all in cooling mode, they would all be wide open with all of their expansion valves. The condensing unit would be running maximum capacity, and it'd be like a regular split system, except your evaporator coil is in pieces in different rooms. If they all go to heating mode, works the exact same way. Reversing valve flips for the heat pump. Now my outdoor unit becomes the evaporator coil, my indoor units become the condenser coils, and in this case, all of the expansion valves are wide open, so I got full flow. That's all pretty logical and works kind of like a heat pump, except I have multiple indoor units. Then what happens if I have some zones that want heat and some want cooling? So now I have I have 4 tons that want cooling, and I have 1 ton of heating, 12,000 BTUs of heating. So what ends up happening is the outdoor unit goes into cooling mode because more zones want cooling than heating. He runs at 3 tons of condenser capacity, even though I have 4 tons of evaporator capacity requested. And that other zone that wanted 1 ton of heating, he's a 1 ton of condenser coil. So I have 4 tons of evaporator coil here, and I have 3 plus 1 ton for 4 tons of condenser coil. It just so happens that one of the condenser coils is inside the space. In that case, my compressor, one of them shuts off, and the other one ramps down to 4 tons. So I'm getting 5 tons of heating and cooling capacity for the heat rejection price of 3 tons for the compressor horsepower of 4 tons. If more zones wanted heating or cooling, same kind of thing would happen. The outdoor unit would switch to heating mode. Now I have 6 tons of heating being requested, 2 tons of cooling. So the cooling guy becomes an evaporator. These 4 guys with the 6 tons of heating become condensers. The outdoor coil becomes the other 4 tons of evaporation. So I have 6 tons of refrigerant evaporating, 6 tons of refrigerant condensing. The compressor is running at 6 tons total, even though I'm getting total of 8 tons of capacity. So it's kind of sweet. It's like I'm getting, in this case, 2 free tons of cooling, whereas over here I was getting 1 free ton of heating. Just taking it from the other zones, moving it from zone A, putting it in zone B essentially. And then in the perfect scenario, if I had everybody balanced, I have 4 tons of heating requested, 4 tons of cooling requested. Okay, all the coils outside would shut off, and I would just be using this compressor as a circulating pump to move the 4 tons from 1 zone or 2 zones to the other 2 zones. So this unit that I showed you before, this is actually the outdoor unit, like we were just talking about. This one is the condenser if I'm in cooling mode, or it's the evaporator when I'm in heating mode, and it can go either way, as we were talking about. So the one we have here is the 3 pipes like we mentioned, and those go across our lab, and we'll go down there in a minute, but they hit 3 ceiling mounted units as well as 1 high wall unit. And we'll talk about how those guys pipe out. This one's a little intimidating. I left just 1 screw in the panel just so I can open it up easily, maybe. So as you can see, there's a lot of stuff going on. So this is not something you want to just show up on a job site and just start working on. We have hands-on classes for this that we do here in the lab. So if you're local to the Chicagoland area, you definitely want to sign up for some of that stuff or request a class with us so you can figure out how all this stuff works. There's a lot of electronics on here. We have inverters for the compressors. There's multiple compressors. There's a lot of piping in a small space. So you definitely want to come to class to know how to work on these units, how to install them, and how to operate the control systems for them. Let's go take a look at the indoor unit side, which will be the evaporator or condenser coils. Let's go take a look at some of those. All right, so the 3 pipes are coming down from the outdoor unit. They're gonna loop back around in this case. Now, we're looking at one of the high wall units here. As I mentioned, the same system has cassette units, ducted units. You can even have floor consoles and stuff like that. But the first one on our piping run happens to be a high wall unit. So the 3 pipes are gonna come in to this flow selector box. This is a single zone flow selector box. There are other versions, like we talked about, that you can have multiples, but this is a single. So it's gonna come through here. We just have a bunch of solenoid valves in here. And essentially what's gonna happen is I'm gonna have 3 pipes coming in, 2 pipes going out. And the way I like to think of it in my mind is I'm gonna have a hot gas pipe and a cold gas pipe, right? And I'm picking whether I want to have hot or cold fluid coming over here to my unit to cool or heat the space. So I got, in this case, 4 solenoid valves. You might have some with 5, may have some with 7. Just kind of depends on how many zones and stuff you have on here. On the piping side of the equation, I have a liquid line, which is the little guy in the middle. And then I have a suction gas and a discharge gas. On the outgoing side, the indoor unit, I just have a liquid and a gas line, and they change their jobs as I change my modes. And then the 3 pipes would run along the rest of the wall. They'd go to the 2nd unit, 3rd unit, and 4th unit. I might have different style indoor units, but they're all gonna work the same way and they're all gonna have this same kind of selector box.